So I start with an overview of the software, then I'll talk about this GXS system, and finally explain to you how you can use it to create decentralized applications. And it's more a call of help for developers because we really need developers in our team. So Retroshare is authenticated links. For this, we use TLS, and we use the TLS over TCP, UDP, but also over Tor, optionally, and I2P. So on top of this, we have implemented a few services that allow to distribute some data. The first of which is file transfer. So it's an anonymous end-to-end encrypted file transfer with swarming capabilities. An email system that is completely asynchronous. Distributed chat that works pretty much like IRC. Forums. And channels which allow users to distribute authenticated data while allowing anonymous users to comment on the post. So Retroshare is available on macOS, Linux, Windows. It's also about to be available on Android. We have a prototype for now. The project is about 10 years old now. GXS was mainly designed by Dr. Bob, Chris, and myself. We don't have many users. It's hard to estimate exactly how many, but we estimate it to be some thousands simultaneous users, which we explain by the fact that it's quite difficult to bootstrap. When you install the software, you have to connect to someone, right? If you're alone, you won't see any data. So either you convince your friend to use it or you join an existing network. But once you're done, you belong to a perfectly decentralized, reasonably secure, confidential network. So it's all implemented in C++. It depends on standard libraries. And we have a graphical user interface in Qt. And all these systems, channel, forums, email, they're all based on the same abstract distribution system, which is the subject of this presentation. So what is the problem? We have a mesh of computers which only talk to their neighbors, and we want to distribute data beyond friends, right? And we want to do that while favoring interesting content, preferably, but also preventing flooding attacks, spams, and provide some guarantee of authentication or anonymity depending on the kind of usage. And finally, the network does not look like this nice graph. It looks more like something like this. So that's a snapshot of what I can see from my own node. And as you can see, some people have a lot of friends, some don't. And also these connections, they might not be working at the time of exchanging data. So we need to be robust to all these problems. So we designed this generic exchange system, which stands for GXS. And it takes care of the distribution, authentication, privacy, and security of the data. And it's based on two principles. The first one is that subscribers advertise to friends. That means when you want to access some data, you will subscribe to it, then you get the data from your friends. And once you're subscribed, you make your friends aware that this data exists and they can subscribe, etc. The second principle is that the nodes in the network, they all participate to data integrity and spam control, flooding control, etc. And on top of this, the services are implemented. So at the core of GXS, you have three blocks. One is the encrypted storage, for which we use SQL Cipher. A network synchronization component, which accounts for who is able or who has the right to see which data. It's based on some kind of multi-chain transaction system. And the last block, the third block, is the validation, which checks the signatures of all the data and pass the data to France when it has been verified, validated. So from that, specific service implements their own private data types. For instance, if you implement forums, you would have like forum message in your private data types, or maybe the name of the forum. They also define what should be the synchronization and authentication policies for the service, depending on the kind of service you want to implement. This can vary quite a lot. And also implement specific actions. For instance, for the distributed or asynchronous email system, the email service has to take care of removing messages when a return receipt has been received, etc. So that works as I will describe now. We have these 5 things: services, groups, message, identities, and cycles. So service is, for instance, a forum is a service that would explain it. Service distribute 2 things, groups and messages, which are hierarchical objects, right? And they differ by the following. Groups have their own distribution of and authentication policies. So the distribution means who will see that data, and the authentication means whether the messages in this forum or in this service has to be signed or not by their users or by their author. So the signatures, they are provided by identities which follow the groups where they are used. And that can be grouped into cycles, which in turn are used to handle the distribution of data, or to limit the distribution of the data. So, for instance, I was talking about forums. If you want to see what it is for forums, then each forum is a group, and the message in the forum will be GXS messages, and then the cycles will decide who is able to see that forum and to post into that forum. If we go deeper, so I won't detail this, but groups and messages, basically they have two parts, the metadata and the private data. So the metadata is what GXS uses for the synchronization. You can see, for instance, in the group metadata, the cycle ID, which is what limits the visibility of it. And the private data is what the service will use for the specific application that you have designed. As I said, identities follow the groups. They are synchronized on request, and actually they are handled by a GXS service. So it might become a bit complicated at some point, but this allows us to benefit from a lot of the existing infrastructure in GXS to synchronize the identities. As you can see here, they can be optionally signed by a node key, which allows this identity to be connected to someone in real life in the network. But this is optional. Some identities might otherwise be anonymous, and then there is no way to trace them back to their hosting node. Cycles are also distributed by a GXS service. But now their subscription and synchronization is automatic. And the system works the following way. To be a member of a cycle, you need 2 things. You need to be in the list of people that are invited to this cycle. So this is controlled by the author of the cycle group, which acts as an administrator of this group. And you need also to have requested membership to this cycle. So this double check system allows the administrator of the cycle to control the members, but also it allows each member to leave the cycle, and nobody can force someone to be in a cycle and, for instance, use that cycle to distribute unwanted data over the network. Also, an interesting bit here is that cycle being groups in a GXS service, they can be restricted to a cycle themselves, including the same cycle. And if you do that, you obtain a self-restricted cycle, which will be only visible to the people that belong to this cycle. So it allows us to distribute data in a very confidential way throughout the network. Authentication works the following way. So there are in groups and GXS messages, they come with signatures. Groups have their admin signature, of course, which controls everything. And they optionally have an author signature, but the group can be anonymous. GXS messages have an author signature as well, if it's required by the group authentication policy. But they might also require a published signature, which will be able to control that some users have write access to some groups. So all these signatures are checked by every user in the network when distributing the data. Yeah, that's it. What about synchronization? So it works on using a cascade algorithm, which basically does the following thing. So each peer acting as a client here will broadcast to his friend the last timestamp of that friend's data, which was previously sent by the friend to the client. Right? So that doing so, we only compare the times that have been issued from that machine. We never compare times between different machines. If this server realizes that his data is new, then he will send the list of new groups here with the published timestamp of each group, to which the client will ask the list of groups he wants to get an update of, and then get the group data. It's pretty much the same for messages, so I won't detail it. The only thing I want to add here is that some of these transactions are actually encrypted to be able to limit the visibility of the data and the accessibility of the data to the persons that are actually in the cycle of identities that are allowed to access it. So we had to add the reputation management system. When you design a system like this, you get trolls, and we got big trolls. So we had to do that, and actually it's quite efficient. There is a chicken and egg problem here, because you want the newcomers to be able to post some data and to bootstrap that data, but you also want to prevent nasty users to create new identities to post new data, right? And because the network is static, it's possible to actually find a good compromise between these two. So what we do is we only forward, we always receive the data, we only forward if the identity has a reputation score that is larger than what has been defined for the group of a specific service. And that reputation score, it is computed by mixing your own opinion about an identity with the opinion of your friend nodes around. Okay? And that allows to block spam very efficiently without the need to validate everybody in the network on every node. Finally, what about file transfer? So we cannot distribute files in GXS messages. It would be too much because of the redundancy of data through the network. And so we designed a system that is based on the Turtle friend-to-friend system. It's anonymous end-to-end encrypted tunnels that, well, I won't detail the encryption there, but in the question, if you want more information, I can give. So what do we do with that? Well, the question is, how much does it take to implement a service? For instance, suppose you want to implement forums, which we did. How much code does it take? The answer is like 200 lines of code plus the graphical user interface. I'm not cheating. So here, for instance, you would need to create your forum service, which derives actually from the GXS service. It's a base class. And you pass to this service the authentication policy, which here means that root messages are signed or required to be signed by the author, and child messages are also required to be signed. Why do we separate the two? Because that allows you, for instance, to create services where the messages needs to be signed, but you can have anonymous comments on each of the posts. Then what about the forum message? I want to post a forum message. Then that's the actual class. I haven't removed anything. It just derives from an existing GXS message object. It provides a serialization process, which is quite compact. And this is the message that you post in the forum. That's all. So when you want to post the message, the operation is instantiate that class. But for forums, we did one already, so you can see that it shows quite a large amount of information. I won't detail it, but I ask you to try the software. So what do we want to do with that? I think that it's possible to use the same principle to develop at least these things. So I just dumped what I had in memory. These three we have started already, but we would really make good use of developers to create them. Ultimately, our target is this Facebook-style decentralized social network where we would like have some wall system where people can post their ideas, whatever, and other users could comment. So it's quite possible to do this using groups, subgroups, and GXS messages. So I'm done. So it leaves me like 5 minutes for questions. You will find a lot of information here. I would like to thank freifunk.net for financing my come here. Thank you. And this is Joe. So if we have questions, we will share probably, depending.
Hello, thank you for the Retroshare projects. I've known about it for quite some time, but I hear you talking about identities. How many identities can a person have?
There's no limit.
There's no limit, no. So you can have multiple identities and multiple groups. Okay, thank you very much.
That's the problem we had with spam, actually.
Sorry, what?
That's the problem we had with spam, because spammers would like create new identities every post. And
exactly.
Hi. I had a quick question, because you mentioned that part of the goals for Retroshare is to have to protect its users' privacy, but at the same time, like the network entirely relies on friends-to-friends connection, meaning that I actually show the entire network who my friends are. And like, is there anything done to protect that information and to also prevent my friends from seeing like who other people I communicate with?
Okay, so there's actually a wide spectrum of users and usages. So we had to offer different compromise to users. So if you want the most visible network is when you enable the discovery system, which advertise to your friends, your own friends, if they might want to make friends with them, right? But you can disable that. So if you disable that, your friends will not see whatever is beyond your own node. Then you might also want to hide your IP address from your own friend because you have a connection to them so they can see it. If you want to do so, then you can use a hidden node, which works over Tor, and then you only see connections to localhost, the localhost proxy thing, and your friends don't even know where you are and who you are.
Okay.
There was a question. You still want a question? So you mentioned that at some point you got trolls or spammers, and I'm kind of interested at the story of that. At which point, when you develop this kind of tools, do you understand who that was, or was there a specific point where things changed?
We don't know who it was, but when you get spammed with messages that become aggressive or sometimes very offending for the sake of like polluting the data, you have to do something always. And it's a shame that we have to do that, but we have to.
And about that, it's like the system, the control over content is so distributed, so everyone decide what's content is appropriate for them or not. So it's like actually it's a system that doesn't need police because everyone is taking care of the control of the content that is now distributing.
Yes, what he's saying is that there's no way you can ban someone from the entire network. You will just not see the guy anymore and not forward his data to your friends. That's all.
So you mentioned there's one of the large areas of outstanding work has to do with the UI, and I imagine a good chunk of that 500,000 codes of the project is going to be user interface. Have you considered, given that there are plenty of open source projects for mail clients and forum clients and this stuff, like to expose, IMAP or NNTP protocols and let the user use one of the existing clients?
Yes, but then you would need to connect somehow to the ClearNet, right? We don't do that. So, there was some experiments where someone implemented some kind of gateway to forward real email into Retroshare email system. So that is possible as well, but it's really a prototype. It's not in the main application.
Thank you. Thank you for making and sharing Retroshare. I just have a very quick question. I just installed it on my Mac here, and I think your target audience are people who care about anonymity, etc., and security a little bit. I just realized that the app itself doesn't have a code signature, and it still tries to connect to places like displaymyip.com, etc.
Yeah.
And so the app could be changed. Have you considered putting it on the App Store and having it sandboxed?
No, not yet.
Okay, cool. That would make me feel better about downloading it. I checked your SHA-SUMs and whatever, but it's still.
About we provide signed builds, of course. In particular, that GitHub does not allow us to have a HTTPS connection to their website, so we have to sign our builds. And yeah, that's pretty much it.
But if you know someone that would volunteer to package it, sandbox it on Mac, we would help.
Time is up. Thanks, everyone.